For application with variable speed drive or variable electric frequency, commonly is fed using a power converter, in this case voltage source inverter. But at previous presentation we heard that the power converter is really an interface between the final application and it might be, for example, between the grid. So the flexibility of this power converter allow not to limit the final application to 3 phases. We could, for instance, just extend the topology and add another leg to the converter and get a multi-phase converter. That is easy for power electronics, no trouble. Now, what we would supply with this converter? We again have to build a multi-phase machine. Multi-phase machine is an extension of 3-phase machine. It's very similar. It can operate with the same principles. It can be synchronous or inductive. It can be designed with different kind of winding distribution like sinusoidal, quasi-sinusoidal, or concentrated one. But what is actually one of the, what is new in this approach? We have higher number of degree of freedom to be covered. But for people who work in control, this is no problem. They are happy with higher number of degree. Okay. This higher number of degree, for instance, for a distributed winding system, can be looked like this. The traditional 3-phase systems obtained by 2 orthogonal reference, but plus we have a series of RL cycles that only provide losses to the system. In distributed winding, is now desired current in these planes, extra degree of freedom. So usually should be kept to 0. And one of these always is the 0 sequence one, that it cannot be omitted also. So what is actually the current state of the technology? First, features of this multi-phase system. With using multi-phase system, we could be better distribution of power per phase. That is an option, an alternative to multi-level approach that is distribute the voltage in the final application. But also we had better fault tolerance compared to the traditional 3-phase. If we lose 1 phase in 5 phases, we still have 4. We could still make it work, the system. In concentrated winding, injecting harmonics or low order can be obtained a better efficiency in the torque production. That's why I asked you, is you use multi-frequency output current, what is happen? Okay. Currently we have 2 potential approach to use this instead of the traditional 3-phase systems. One of these is the 5-phase, and the other one is asymmetrical 6-phase that can be also configured with a single neutral point or using two different 3-phase with 2 isolated neutral points. That is the 2 potential currently this technology. Okay, for a renewable energy system, considering for instance 1 generation, we could see the following properties. Both are suitable for medium high power, of course, but if you compare the 5-phase with the asymmetrical 6-phase, the main feature that could be highlighted is that asymmetrical 6-phase machine has flexibility with 3-phase system. Why? Because 3-phase is the traditional one. We had converter, we had lot of controller and areas. Okay, and this is why usually and currently for 1 generation usually are used the asymmetrical or to extrapolate multiple three-phase system. Not only two, it can be multiple. The number can be four three-phase, so we have 12 phases, and where else? Okay, how to control this system? Traditional control, like vector control, had been extrapolated for the multi-phase case. It obtained a similar result. However, as you can see, we had higher number of degrees of freedom that imply higher number of controllers. Even when you have distributed windings, you need to inject current in the complementary planes. Why? Because dead times in the power converter usually introduce current, undesired current, stator current in this plane that only produce losses. So you should to control it, and this is one of the main challenges in PWM modulator that usually, currently I make it with traditional sine PWM. Okay, for this case, it's very analogous to the three-phase case, with the extension of the controller that make a complexity. However, in using the vector control, we had always low flexibility for extension of the control criterion. We should make a lot of arrangements to get another control criterion. The other traditional control scheme is the DTC that has been also used for multi-phase. However, in this case, the performance of DTC is not as good as in three-phase. And why? Because traditional DTC only consider flux and torque that cover only 2 degrees of freedom. And in multi-phase, we had more than 2 degrees of freedom. And the other degree of freedom is very difficult to be introduced in this structure. There's some approach using virtual vector that is an average voltage vector with 0 volts in the other plane that is used in similar two comparator implementation of DTC. Okay, I told all the features. The new one strategy is the predictive control that can be used to control current, to control torque. Also, there is a flexible technique that can be used covering also the extra degree of freedom without problem and have the standard for the multi-phase converter. I just make it short because the next presentation is of this topic. Multi-phase, the performance of predictive control in multi-phase has been evaluated, and the only difficult is the complex model that require powerful digital controller, but it's not a problem currently, and flexibility can be used to include another criterion, not only current or flux or whatever. Okay, we have the control, we have machine, we have converter. So we can use it in renewable energy system, and the main area are energy generation and electric traction propulsion, that both are from the green agenda currently. That is the main subject that motivate the development of multi-phase systems. Okay. For one generation system, we could use, if we have multiple three-phase machines, we can use association of conventional three-phase converter and conventional topologies to get exactly a generation system that can be also provide fault tolerance. However, this fault tolerance is limited to deactivate the interior faulty converter or line. We don't have possibility of reduce or increase more than this in one case of faulty appear. However, we could still use the flexibility of the system and associate, for instance, for 6-phase, two three-phase converter, series or parallel, to get some features. For instance, in series association, we could get medium level voltage of the generator's side converter, and in parallel association, we can provide better fault tolerance to the system. For instance, okay, the more classical approach for fault tolerance is open wide case that consists is just leave it open the faulty line and control the machine with the other lines. For the case study covered in this subject, we have log of approach using open fault, open phase techniques. However, if we analyze this particular topology, for instance, for 6-phase machine with both configuration, common neutral point or two isolated neutral point, we should inject current undesired current in the system to make it still work to the machines. And this, what is the result of this? Are losses. You should admit losses in fault tolerance. For generation system, it's not very good admit this kind of losses. It are not higher, but higher than expected. For instance, in order to improve this characteristic, we could consider instead of just leave it open the faulty phase, why not connect to the half point of the DC bus? And in this case, considering the isolated neutral point. The behavior of this system are governed also for the balance of the capacitors. Since we have another converter in the grid side, we could balance this capacitor with a specific topology like MPC converter. So we can just consider that always is balanced this voltage, and develop the traditional model of based on modulation techniques. So if we are able to modulate, of course we will be able to control the current and power flux. In this proposal, we only had 5 legs to control 4 degrees. The proposal is a modulation technique based on a traditional 3-phase PWM system and an arrangement in using the same reference. It's virtual reference also. And this arrangement is very easy to implement. It's just, let's see, this is traditional and this is only this equation applied. That is easy. We have mass of constant, this is reference, and this is a value that depends on the balance of the system. So if we consider utilization of the modulation technique, we could get a half utilization of the healthy system. But it's more that 1/2 is 1/2 and a little bit more is, I'm not sure, is 15% more than only the halves. So we have that extra power that can we use in fault tolerance. It's lower than open faulty. However, if we use this in controlling also the additional degree of freedoms, for instance, injecting not only fundamental but also another harmonic to control the undesired current, we could control the machine exactly like the traditional vector approach and get zero current in the undesired plane. So only the traditional DQ component will be excited and the XY plane is keeping to 0. If we show these are shown with a speed loop, we could still see here that DC bus utilization is, we had still a DC bus utilization availability. So we could in this range reach the maximum torque, for instance. So it's a possibility that, and we don't have to admit losses in undesired planes. This is all my presentation. As conclusion, I would like to remark that multi-phase machine can be exploited in this kind of application with better distribution of power, fault tolerant, and using as currently the multiple three-phase system. The problem with multi-phase system is that it's still in development. It's not really maturity. Also, this is recently proposed and should be make another evaluation with another topology like ACC converter and other one. So this is all. Thank you very much.